Hello, today we're going to do an AP problem about zombies. Here's the problem. A zombie walking along a path has its velocity modeled by the equation v of t equals 4 cosine pi t plus 2t for 0 to t to 8. The zombie's initial position given by the function x of t is x0 equals 5 meters. Position is measured in meters and time is measured in minutes. So, first you kind of want to get the important stuff down, like the equation v of t equals 4 cosine, which is right there, handy dandy, already circled. The interval, the initial position, which says right there, and it's right there, x0 equals 5 meters. But the first problem simply says, is the zombie speed increasing or decreasing at t equals 0.5? Justify. Well, in order to find the zombie's speed, if it's increasing or decreasing at time t equals 5, we need to know velocity and acceleration. Well, we know velocity because it's given right here in this equation. V of t equals 4 cosine pi t plus 2t. Alright, now we just need to find acceleration. Well, all we need to do to find acceleration is take the derivative of velocity. So let's do that. And you should get a of t equals negative 4 pi sine pi t plus 2. Now that we know acceleration and velocity, all we have to do is plug in the points. Well, this is a calculator active problem, so let's use the calculator. Alright, so plugged in v of 0.5 and I got 1. A of 0.5 I got negative 10.556. So that means they're different signs, so the speed's decreasing, but it said justify our answers. So looks like we gotta write that down in AP format. So if we were to write down AP format, then we would say the zombie's speed is decreasing at time t equals 0.5 because v is 0.5 and v of 0.5 is greater than 0 and a of 0.5 is less than 0. So that's the first problem. It was fairly easy. Now we gotta do the second problem. The second problem says, at what times is the zombie at rest? Well, if we want to find when the zombie's at rest, that's the same thing as saying we need to find when v of t equals 0. So we can just write down v of t equals 4 cosine pi t plus 2t and then set equal to 0, or we could just plug it in the calculator. So let's go for that in y equals, and you should get something that looks like this. So as you saw, the first, it looks like there's 3 zeros, but this is in the interval from 0 to 8. Right here. The first one is definitely before 0, so there's only 2 zeros. And now we are just gonna go select 0. Looks like the first one is at 0.5963. Do the same thing for the second one. And it looks like the second one is at 1.2791. So, now we should write in AP format. The zombie is at rest when t equals 0.5963 and t equals 1.2791, because v of t equals 0 when t equals 0.5963 and when t equals 1.2791. Well, that's 2 questions already done. Let's look at question C, or question number 3, however you want to look at it. Here's question 3. On the given interval, what is the zombie's maximum position when the zombie's furthest to the right? Justify your answer. It's basically, this question is saying, when is the y-coordinate for position the greatest? We don't have position. How are we going to get it? We're going to take the interval of velocity. So you put the interval sign indefinite, because we don't really have any points. V of t dt equals, obviously, position. So you get 4 sine pi t over pi plus t squared plus c. Well, what's c? Now we got to solve for c. So, but how are you going to solve for c? You don't have anything, but you do. Remember, t of 0 equals 5 meters, and that's on the position graph. So, now we know that for that position function, if we plug in 0 for t and 5 for y, we should be able to find c. So, plug that in, and we get c to equal 5. So now we know the total equation for position is 4 sine pi t all over pi plus t squared plus 5. But it's asking for the maximum position. We don't have any points. This is a calculator active problem. We can use a handy dandy calculator. So, we're just going to type the equation into the calculator. And it looks like you can't see many of the points. And really all you see is this weird squiggle. So what you do is you probably see something like this. So what you need to do is go ahead and just exit out of that. Then just do alpha, trace, and then just the y coordinate that you want. So now it just says y2. You put parentheses, the first coordinate, which is 0.5963. No, it's not. Since we're making a table, we're going to be using the x coordinate 0 first, because that is the left side of the table. So we plug in 0 and we get 5. Well, that's a relief because we wanted that to equal 5. So we know that our C is correct now. And we know for the x of when x equals 0, y equals 5. Now we got to plug in the other three coordinates, which are 0.5963, 1.2791, and 8. So we plug those in. And it looks like 8 has the largest y value of 69. So let's just go put that in AP format now. The zombie's maximum position is 69 at t equals 8. That wasn't a difficult explanation at all. So now we got to look at the last problem, D. The last problem is this. On what intervals is the zombie's position decreasing? Justify. Well, if we want to know when position is decreasing, we can also just figure out when velocity is negative. So now, since this calculator active, handy dandy calculators, we just get the y's, or in this case, just the normal points, from the velocity graph. So if you put in the velocity for y1, you should get this familiar graph. And it looks like the only negative points after 0, because the interval is from 0 to 8, are somewhere between 1 and 0 and a little after 1. Well, we know those points. We found those critical points already. We know the first one's 0.5963 and the second one's 1.2791. So now we got to put it in AP format since it said justify. So the zombie's position is decreasing from 0.5963 to 1.2791 because v of t is negative from 0.5963 to 1.2791. And now you're finished, finally. Nothing else to do on the problem, except maybe write your name and turn it in, but that's pretty much it.